I don't want to hold this. Kia ora, my name is Patrick. I'm here at Paul Component Engineering International Galactic Headquarters, as Surly would say. And we're here to talk to you a little bit about this here lathe mill and some tooling and why these are cool. I know we've already done a video, but we're going to do another one and we're going to talk about some other stuff and it's going to be great. And this is the intro. Welcome back on this Weird Word Wednesday. I'm Patrick again. We're here to talk about one of our new machines. It's actually an identical machine that we have downstairs, which we've already done a little video on. So I'm not going to talk too much about the machine. It's a twin spindle, live tooled Y-axis lathe mill thing. These things are awesome. We're really seeing the power that these things can provide to us and getting parts to you quicker. We do run them overnight, so lights out machining. And we want to talk a little bit more about the tooling that goes in these and why this is all coming together and some of the cost benefit breakdowns for all this. But it helps us help you get parts to you quicker. And that's the name of the game, just in time, baby. The vastness of the space in front of me contains some of the tools that we use in these live tool lathes. And they, they're a lathe, so they take standard stick tools. So just, this stationary part spins into it. This is for threading holes. Beep, beep. We got a knurler that we made in-house. Paul made this on his shaper. It does actually make money sometimes. That's for knurling things. And then these are live tools. So these are spindles. So they're like a mill that's inside the machine. This is a twin spindle Y-axis live tool. So you can put tools in here and that allows you to machine features into a part just like you would on a big VMC or something, but on a smaller scale because it's a littler thing. These are really expensive. The machine's really expensive, people are expensive. We love our people, we love you, and we invest in our people, but we also have to repair these and have backups of the ones we have. So if one goes out to repair, we have another one, and you need a lot of them to do multiple different features on a part. But we're an American-made company. We make everything here. It's a lifelong product. It's really high quality, really high tolerance. Things fit together. They fit together really well. Assembly doesn't have any issues, usually. When they do, it's pretty minor, and then we address them because we can do that because we make everything here. So just wanted to kind of cover some of the reasons it costs money to make things that are nice. Why do we buy these machines? Well, one reason is it can do milling. It has two spindles, so you can finish a part complete in one operation, and you can feed it with a bar loader, so it's essentially automated, which I've talked about before. But once it's automated, you can run it overnight. You get an extra shift without another person here. It's one of the main things is it relieves fatigue on the operators. So instead of having someone stand there and load, this quick release lever into a chucker lathe and run this for 30 seconds and do it again, hit go, do it again, hit go. That's very draining on an operator. Now we can use them more for their brains and their personalities than just a human robot, essentially. So we're investing in equipment that takes some of the fatigue off the operator. It also increases throughput. We make more parts, but it's also freed up a lot of the mill time. So we used to make our pad adjusters, which go on the clampers on the mill. So we'd make it out of rectangle stock. We'd machine it, even though it's mostly round, it has a lot of mill features on it. And that was one of the first things we did, is to put all of those type of products onto one of these machines. And it allowed us to automate a lot of mill jobs. And the mill now becomes free to make clamper bodies or something else, which allows us to get more product through the system quicker. There are 7 components inside the clamper that we make here in the house. And so 4 of those went onto a mill turn, and then the other 3 are still made on the mill. So, and all 7 of those were once on the mill. So that freed up basically, I don't know how many hours of machine time, but a lot. So it allowed us to make more clampers quicker to get them to you. In addition to that, Paragon Machine Works actually used to make our lock rings, and apparently they sold the machine that they made them on. And that was right around the time we got our first one. So we started making our lock rings here in-house, which is fun. And then you know, we engraved a little P on them. So now they have a little P, which is cool because P is for Paul. And then it's also allowed us to create new products like the bar end plugs. These are made because we have the capability, and our design constraint went from, you know, we have a mill and a lathe, now we have something that can do things a little more complicated. So our designs have changed, and we're allowed to, it allows us to make new products with that in mind. It allows us to bring old products back, permanent pivots for all you frame builders out there. Shout out. But an example of what I'm talking about is our axles is another. And we're slowly adding all this stuff because it takes a long time to program, a lot of investment up front to actually get these products on there. It's like redesigning, remaking everything we've done. So this is a high flange axle without the nuts and not inside of a hub shell. We used to do these in 3/8. So you'd hold it like that. It'd be bar stock like this. And we'd machine, you know, this. We turn it around, machine, you know, that. And then we hold it between centers, meaning there's a tailstock comes in, and we machine the center of that. So that was 3 operations that someone had to load. That's 3 setups. Takes a long time. There's a lot of whip, work in progress. So the parts sit around on a shelf. You know, you got to track it. Now we can just spit this stuff out. That machine just makes it 2/10, you know, plus or minus, no big deal. So it's a huge step forward, and we're constantly looking at new equipment, new ways to do things. You know, the future is now. Did I already say that? But sneak peek, we're doing some really complicated stuff, and I'm very proud of this setup. But this is bar stock, and out of that bar stock, we've started making our hubs. The low flange we do one and done, meaning they come off complete. Whereas used to be 6 operations, it is now 1 operation. So with enough time, money, and ingenuity, you could make cool stuff. Finish it up. Okay, this is where we cut back in, and here we are, we're back. If you have questions, comments, concerns, you can reach out to paulcomp.com. Somewhere there's an info thing. Finish strong. Wait, I have something. Hold on. May the moon beams dance in the sparkle of your eyes. Thank you. Oh God. Get the hair out of your eyes. I got an A in my Eastern religions class. Half the time I don't know what's going to come out of my mouth before I say it. Hi there. Tickle me shimmers, this is Patrick with Paul Engineering. All right. Hey there, Patrick, Paul Ramekin Bamakin, I'm Patrick with Paul Engineering. Hello. I don't need to say hello every time we do a new scene. More content on that in the future, so stay tuned. Smash that subscribe button.